So, there's two sub-terms that fall under the prevalence, and we have period prevalence, point prevalence, and then mortality rate is kind of its own epidemiological term. With period prevalence, this is the number of cases of a disease that exist in a given population during a specific time period. So if we wanted to look at diseases in a specific time frame, say the year 2009, that would be considered the period prevalence. Looking at just simply the number of cases of that disease in a specific population at a specific time. And point prevalence is the number of cases of a disease that exists in a given population at a particular moment in time. So this may be something like at a specific period, which could be right now, okay? Or it could be a specific day, like on Tuesday. So point prevalence is simply the number of cases of a disease existing in a given population at a particular moment in time. Okay, so this is more quantifiable in time, whereas period prevalence, we're talking about a specific time period. They're slightly different, but they are slightly similar at the same time. For mortality rate, this is the ratio of the number of people who have died due to a particular disease at a specified time period in a specific population. So notice how like prevalence and these rates are always about specific time period and specific population, and then for mortality rate, this is actually going to be a ratio of the number of people who died at that particular time. Okay, so you would see something like 1 out of every 10,000 individuals died at a specified time in a specific population. So that population would be 10,000, and then the one individual who died would be the 1 out of 10,000 ratio. And again, you specify the time frame for that. So that's what we talk about. That's what we mean when we're talking about mortality rate. So one example that we can talk about is that of HIV prevalence. And this diagram is kind of old, it's from 2011. But in this diagram, we're looking at the prevalency of HIV among females as well as males. And these females and males have kind of subcategories, or have been grouped into subcategories. So females who undergo intravenous drug use have a high HIV prevalence of 7%. Males who undergo intravenous drug use are going to have a high prevalence of HIV at 12%. High-risk heterosexual females, 18%. High-risk heterosexual males, 9%. And 48% in this particular diagram, what this is saying 48% males who have had sex with other males have there's a 48% HIV prevalence in this particular category. Okay, and then 5% of males who have had sex with other males, as well as who have used intravenous drugs, only have a high HIV, are 5%, have a 5% prevalence for HIV. So what this diagram is showing is just the prevalency of these different subgroups in terms of being infected with HIV. And this is kind of data that epidemiologists are going to look at and look for and try to make the connections to see what members of the population are highly at risk for acquiring HIV. HIV in this diagram is prevalent in every single one of the individual categories listed, but it's more prevalent among males who are sexually active with other males, which is why 48% makes up pretty much half of this diagram. And so what an epidemiologist do is just make these conclusions from this diagram and then give recommendations to the health department on how to deal with the infectious disease in the population. and what kind of mechanisms to implement in order to control it. So HIV is just is one example of a disease that can be spread among members of the population. And using this is a good model for us to understand the term prevalence, because prevalence just means essentially, well, we have an incident, or we have a number of individuals that are infected with a specific infectious agent. So we look at the time period, we look at the population size, we look at these different factors, and this enables us to figure out how prevalent is the disease. Some other terms that are used to describe disease by individuals who study diseases in populations are epidemic disease, endemic disease, and sporadic disease. Sporadic disease is a disease that occurs on occasion, essentially. So every now and then you see it kind of show up in a population, and it might be in a particular region or a particular geographic location. One example is that of tetanus. It's kind of sporadic, which means sometimes in a timeline of a couple of years, you may see that there's a high number of cases of tetanus, and then a couple years go by and then you see that there's lower numbers of tetanus, and then it's high, low, high, low. So essentially you can have basically these sporadic kind of incidences that will take place on a disease if it's considered to be a sporadic disease. An endemic disease is a disease that is always going to be present inside of a population. So something maybe very similar to chickenpox, like it's just always present. And it could be a population that is localized to a specific geographic region. Another example could be that of gonorrhea, where you just have a number of individuals that are presenting with this particular disease. So it's endemic because it's always present in the population. So every year you're seeing this disease come up. An epidemic disease is a disease that is defined as a greater than usual number of cases of a disease. So an epidemic could be basically an escalation of an endemic disease. And with epidemic diseases, though, they differ from endemic because they have a particularly short, they particularly occur very quickly. There may be a very short period of time that goes by, and then all of a sudden you have all these people that are infected with an infectious agent. So essentially you have some sort of outbreak, and then there's a lot of scurry on public health officials to figure out what's the source of the outbreak and how can we control and manage it. And one example is that of Legionnaire's disease, which was an epidemic of 1976. So the Legionnaire's disease epidemic of 1976 came about because there was a convention of American Legions in Philadelphia. And some of the attendees that went to this conference started presenting with chest pains and lung complications. And 3 individuals that attended the conference in Pennsylvania ended up dying. And through kind of the process of backtracking and making these observations, they were able to go back to the origins of find the origins of the epidemic and tied it back to the Philadelphia American Legion conference that took place. So an epidemic disease, as an example, is that Legionnaire's disease, because it's not highly prevalent in the population, but all of a sudden there's a lot of individuals presenting with these symptoms. And so that's kind of an example of an epidemic disease. Zika virus right now is epidemic. Ebola 2 years ago, was an epidemic. And a lot of times epidemics can be very scary because these, in a lot of cases, are diseases that we're not very certain how to deal with yet, which is why the outbreak is very alarming to many individuals, and we would quickly want to respond to the incident or to patients that are suffering from the disease to hopefully minimize the risk of them spreading it to other members of the population. Now, endemic and epidemic can be kind of hard to grasp, but just remember with endemic, you're going to have disease that's always present inside of a population. With epidemic, you're going to have a disease that's not normally present, but then all of a sudden something happens and you have high prevalence of, or high number of cases of the epidemic. So here's a nice kind of timeline of outlining the differences of endemic versus epidemic. Endemic here, you can see the number of cases of the disease are very low, and they kind of stay with the population for a very long period of time. Epidemic, you can see the number of cases rise very quickly, and that the time that this happens is a very short time frame. And then we figure out mechanisms to control the epidemic, and our number of cases start to decrease. So endemic means naturally present for most cases for a long period of time. Then epidemic means not, you get a high number of cases in a very short time frame. Now it's important to kind of, as an epidemiologist, to determine what is an endemic and what is epidemic. So as you're combing through data, and after years and years of practicing this, you eventually come to the conclusion that you know what is endemic and what is considered to be epidemic. And this is really important to identify because this allows us to identify emerging diseases. So there's a lot of different newly emerging diseases that can be very scary for a lot of people, because there are things out there that we don't really know how to treat yet. So things like Ebola. When we had the Ebola outbreak, it was very, very scary and very traumatizing to a lot of individuals because nobody knew anything about it. All they knew was essentially that the Ebola virus is incredibly deadly, and it leads to dangerous hemorrhaging in the brain. And so when we have these particular diseases that are emerging, they're emerging because when they pop up, we haven't yet figured out the correct tools on how to respond and how to treat individuals suffering from these. So there's lots of diseases that are out there that still require more research and investigation for us to figure out exactly how to protect individuals from acquiring these illnesses, as well as helping individuals learn to cope with them. So Ebola, Crimean Congo, hemorrhagic fever, they all belong to the same family. You can see where these emerging diseases are rising. Ebola, as many of you know, has origins in African countries. We also have yellow fever that you can see in some of these areas. This particular diagram is incredibly old now. It's from spanning 1996 to 2004. But if we had to redraw this map, we would take some of these red dots and place them here on this western coast of Africa, because Liberia and Sierra Leone were the two places that were hit very hard by the Ebola outbreak that happened in 2014. And individuals right now, it's not in the news as prevalent anymore, but individuals right now are still trying to figure out how to recover from from that outbreak. Influenza, we always see kind of a new flu virus that becomes the next scare every year or so. This is kind of an example of a endemic disease kind of for the entire world, because it always seems like we're always combating some sort of influenza. So influenza H5N1, let's see where this has its prevalence. You can see here we have southern Asia, looks like China, where the little blue dots are. Lassa fever, we have that around here somewhere, I guess is here, close to where Liberia and Sierra Leone are located. Monkeypox, there are some diamonds that are here in Africa, and it looks like there's another red diamond here. I won't go through all of these, but just so you know that there are a lot of different emerging diseases. Everyone thinks that disease runs rapid in Africa. In a lot of cases it does, because of the way the healthcare system is and how people don't have access to very simple things like hand sanitizer which could help minimize transmission significantly.